everybody, Chaz Large here with another video for you, and this time it's another one of my modification videos. In fact, it's following on from the Sound Bomb Bluetooth modification that I did, and in that video I promised you another modification, but this time to a radio. And this is the Roberts radio. It's an RD20, it's a DAB FM RDS radio, but it's got brilliant sound quality on it. It's got bass and treble controls which give it a lovely sound, and it works really well. Basically it has not got any external inputs to it. It's got external outputs, line output and headphone output, but no external inputs. So in preparation for this video, I've done a little bit of planning this time rather than a bit of the ad hoc that I did in the Sound Bomb video. So basically I've got some switches which I'm going to mount on the side here, and I've taken it apart and looked inside, and there's a good spare area inside here where I can mount a little circuit board with some push switches on, which will come out just along the side here. I've got a switching socket which I plan to mount probably around about here somewhere in the plastic, and that way we're going to allow to have both Bluetooth into it and also external audio input. And if we look at the circuit diagram, we can see on here that this is the main control board here on the this side of the diagram. The sound amplifier is down there. It's a separate amplifier, but we've got a control board here with the volume and treble controls and bass controls, and we've got the output from the radio on these two transistors, Q1 and Q4. They go into here through the controls, back out here, and into the output. So what I'd like to do is to basically put the input from the Bluetooth into this P11 socket on pins 5 and 6 left and right, so that I can put that in there. But I'll put a little switch in there as well, so that I can switch between radio and Bluetooth stroke auxiliary, because there's no functionality that I can work on with the buttons on the actual device itself. All the buttons here are programmed, and I can't hack into the control system of the radio to make any changes here. So I shall have the buttons for the Bluetooth operation, and also a little switch there, which will, when pressed in, will put either Bluetooth or auxiliary input, and when released it will be just the ordinary radio. So it's just a case of doing a little bit of rewiring on there. So that's basically what I've got. So I've got the socket to do that, I've got the Bluetooth device, I've got my switches, got probably a little bit of VariBoard I use to mount the switches and put it on here. So I'm going to make that all up in preparation, and also take the radio apart so I can get to those connections here on this plug and socket, and I may go into how I've taken that apart to do that, because it may be a bit more difficult than it just looks on circuit wise. So join me after I've got all the bits and pieces ready to go into the radio. Okay, a little bit more research into the radio, and by identifying where things are, I found that the connector that we were looking for on the circuit diagram here, pin P11, that is this socket here on the main board, is just there and there. So I've just had to release this audio amplifier board just slightly, so I can tease out the cabling on here, and identifying that pin 1 of that, which is the ground pin there, on this one here that we can see where my pointer's moving. So what we need to do is to disconnect the top 3, which is pins 4, 5 and 6. That's ground, left and right input, and that's where we're going to now input our signal from our Bluetooth stroke or auxiliary input. As luck would have it, many moons ago I did various modifications to computers and things, and I happen to have left over a spare screened lead from a CD ROM installation which never got used for sound. So this is a nice little screen lead. So I'm basically going to fit that into that connector, and then take this wiring across to my socket. Now, as this is all over this side, I'm hoping that by just bringing that wire across, I can either mount it on this side down here, the board, so that the socket rather for the switching can go there, and I've got enough cable to go across there. So a little bit more exploring about where things can actually fit and how things can go in, then I'll be back with you. Okay, part, I don't know what part, but basically testing time. I've now identified, as I showed before, the connection on this plug and socket, which is down here, and I've disconnected the two inputs to it, wire them up to a little push switch here. So on that push switch now, I've got the common, which is that one, which goes to the amplifier to the middle of the switch, and when the switch is out, we've still got the radio on, you can see, and then when you press that in, the other side is going to a jack plug on the end of a wire, and currently I've got that plugged into my little mini disc. So, and I'll turn the sound up, so I've got the mini disc is playing back through there. So I've now effectively got part one of this working, where I've got effectively an auxiliary input switchable by this switch between radio and auxiliary input. So part one is done. I've just got to tidy this up and mount this switch probably on the side here. I've just mounted it on a bit of Veriboard for now, and I've left bits and pieces of plastic. Let's just turn that down a minute. So that I can mount it off, probably put some little plastic mounts to mount it so that switch can go in there, and I've got a little button lid to go onto that switch, so it just doesn't stick out too much. I'm hoping that there's going to be enough space to do that. There should be, because there's nothing else here on this part of the radio, so it just means there's going to be a switch on this side and some switches on this side at the back to control the Bluetooth part. Right, we're at the next stage. I've fitted the auxiliary audio socket on the side. I've drilled a hole and cut out, because there's actually, on this particular radio, there's actually two layers of plastic, the outer shiny part and an inner plastic case. So I had to mount it in there and then make the hole wider to allow the socket, or the plug that plugs into that, to actually go all the way in, because I couldn't recess it from the inside, so I've had to recess it from the outside. I've also fitted a little push switch, which is changing the state between radio when it's out and auxiliary stroke Bluetooth when it's in. So that's working okay, and I've wired it to the point now where the cable for the Bluetooth device is going to be round here. So I've made a nice long cable that's going to tuck away down the bottom. There's just a little bit of excess there that I've created at this end, mainly because I didn't cut it off short enough, but the cables are all back, and it's wired in the correct way into where the original cables went into the amplifier board. So that's all nice and neat, and it's all done. To offset the switch slightly, let me just focus again on that. Basically I had to mount it with some standoffs to make the switch sit far enough back, otherwise it was sticking too far out into the outside, so I had to stand that back. But I found very useful these sort of like foam bits and pieces of foam packaging, which are really quite tough and solid, but easy enough to cut with a knife or a scalpel. So I could cut those down to size to fit those, and then glue the board onto it. I would have liked a better way of doing it, perhaps mounting some standoff with screw threads, but it just was easier to do it that way. So glued on that side and a little wedge in there. It can always be pushed off and if necessary to get at the switch, but I shouldn't need to because there's going to be plenty of room around anything that's going to sit over the top of there. So basically here's the circuit diagram that I've created for it. So we've got the traditional radio output coming from there into the switch, into one side of the switch. The common from the switch on both channels goes to the amplifier board, which is here, and then the other side of the switch, the Bluetooth stroke auxiliary, goes into the socket. If it's switched to Bluetooth auxiliary, we can have signals going in through the socket, or if we plug in, plug that in, that overrides the Bluetooth. If there's nothing plugged into the socket, then we get the Bluetooth module coming out. So in terms of the Bluetooth module, I've now got to put supply a voltage for it, and if you watch the other video, you'll know that I had to get a 3.8 volt Zener to make like a 4 volt supply, which the sound bomb that I was using had a 6 volt supply. Luckily on here, on this radio, there is a separate 5 volt regulator here on this board, and that comes up to the digital board here, so there's a positive 5 volts there. So I'm going to tack across there for the Bluetooth board, and hopefully that should work, and then also make a little circuit board to go over this side for the switches. Actually they're going to be mounted on the back side there, along that edge there. So once I've done that, I'll come back and show you the results of that bit. Right, here we are again, having made a lot more progress. As I mentioned earlier, I've wired through the audio side of things through to this side. So I just hardwired it straight onto the 5 volt supply, and it works fine. However, I wired it initially with just a couple of bits of wire from straight across there, switched it on, and it was working, but there was so much interference with it, it was just really quite maddening. So obviously it was picking up a lot of the digital noise that was generated from the digital circuit board, despite all this metalwork around it shielding it. So I thought, how can I do this? Well, I managed to find an old USB cable that had got broken one end, and I decided to strip that back so that I've got a shielded cable all the way. And let's just zoom in a little bit on this so you can see a little bit more detail. Yeah, so I stripped it back, and I've used 2 cores of this as a supply to the board and the ground to there, and taken that right across from here, just bringing out the connection on there just a little bit to make it easier to tap into. That's worked a lot better, but it's not fixed it completely in terms of the interference. I'll give you a demonstration of that in a bit. As for the switches, I made a little switchboard with the switches and the resistors as per the diagram, and initially I wired these switches onto this board, measured it all out, and drilled the holes into this back part here to make it work. But unfortunately, what I'd forgotten, when I'd put these switches on, you've got 4 connections to that side, and I'd inadvertently, when I put this on and designed this, I'd inadvertently forgotten that the 2 on the long side of each side are joined together. It's actually 2 switches in one, so the switch contacts is between this one and this one, and this one and this one. And I'd wired it and put it in round the wrong way, so when I went to test it, it was as though all the switches were working, because of course they were shorted out between that line there, that side there, which I made the common ground, and all these other parts. They were all shorted together, so nothing was working. So I had to turn the switches round by 90 degrees so that the switch was working that way instead of the way it was. And of course, where I'd previously made the holes in the side, I had to re-drill them to make them fit. Now, as before with the mounting of the switch on the other side, I've mounted some foam so that when we mount that in there, that foam will support the switches onto the board like so, and then I fix them on there so now the switches are all accessible from the outside. I chose switches which are going to stand out just a little bit. I did try some shorter ones. I've got a whole box of different switches with different lengths here, and I think these are 8mm. I tried the 6 ones, but they were just a little bit too short. So when that gets mounted in there, those switches will be easily accessible. What I'll probably do is I'll make some sort of cover, perhaps a label or something, to cover over all of that, because they need to have a label anyway, and that will cover that up, the holes on there. So a little bit of a shame that I made that error, but I just literally forgot the way the switches work. Anyway, back to the problem with the digital noise. So you can probably hear the high-pitched whine. That's the digital noise coming through. So we can turn on the Bluetooth. That's a little sound. Now, the only thing about this Bluetooth is there is a preamplifier in here, but it's not a very big one. And one slight technical miscalculation that I didn't do is where I've taken the output from this into the volume input before the main amplifier of this board. There's not a lot of sound output on this, so to get the Bluetooth to work you have to have the volume level from your phone or tablet, whatever it is you're connecting to it, to quite a high level. So perhaps what I should have done is taken this, rather than into the volume input, is into the preamp before. But there we are, it's done now. It would have meant taking this whole board out, identifying where the preamp is, breaking into that. It was just far easier to do it where that cable went in, so that's why I've done it. But maybe if I did on another radio, I'd investigate the preamplifier level. I should have realised that the preamp, but even so, it depends again also on the volume level of the music that you've got recorded on your or on your tablet or your phone. So it can be that sometimes is not as loud, or it's sometimes louder. So anyway, let's just play a piece of music through it. So it's actually quite loud, that bit. I'll turn the volume down. So that was at maximum volume from my phone. So if I turn this up to maximum volume, let's clean this volume control, it's a bit noisy. And that's the next track. So functionality, jumping from track to track, is playing okay. Pause. Resume. Yeah. So the whole Bluetooth functionality is working, and it's going through on there. But I've just got to get rid of this whine, this high-pitched whine. Now, one little thought that occurred to me is a bit like Roberts have actually done on this cable here, and also on the antenna cable there, is to see if putting a ferrite core on this cable will help. So that's what I'm going to try. I've again found an old cable that had got a ferrite core, dug it out of the plastic, and I've got the ferrite core there. So I'm going to try just powering it all down, taking these wires off here and putting a ferrite core on here and seeing if that helps remove this noise. I don't think it will, but it's worth a try. So I'll be back after I've done that. Okay, well, I tried putting the ferrite core onto here. It made absolutely no difference. No matter where I moved it, it didn't make any difference. I've also tried putting various capacitors across here and here to see if I could sort of remove any frequencies that way. Again, that digital noise is just getting through. So I'm guessing probably there's more digital noise getting out than anything I do on here can cope with. But of course, if you've got any suggestions as to how to get rid of this noise, fine. I'd be very, very pleased to hear it in the comments below. Thank you very much for that. So I'm basically just going to ignore it for now, because when the music's playing you can't hear it anyway. It's really only annoying because you can hear it all the time, and it's obviously getting into, or may even be being introduced from this into the circuit, because even when I turn the volume right down to minimum you can still hear it. So my guess is it could well be that this is actually this board itself is actually generating the interference. Just had a sudden thought. No, turn the board off and it's not doing it. Right, so not bothered. I'm just going to let it be. It could be a number of things. It may even clear up if I reassemble it all and put it all back with the shielding, because there's a metal shielding on the back of this radio. I say metal shielding, it's also the ground plane, if you like, for the DAB aerial, which is on the other side of this connector here, because DAB really does require a dipole, much more so than FM does. But in terms of that's what this big plate here is on the inside of a lot of these DAB radios. There's a huge metal plate, and it's not just grounding, it is actually the other side of the aerial. Anyway, I'm going to put it all back together, get this board mounted onto the back panel so that the buttons are pressed through, and also mount the Bluetooth module inside the radio, so that keep it as far away from here as the rest of it. And let's see what happens when I've done all that. So back after I've done all that. Right, well, I'm pleased to say that it's done. It's all put back together, and it was just a case of lead dressing. Once I'd put it all back together with the cables tied up, very, very tiny amount of digital noise, but connected to the phone, working absolutely wonderfully, even quite loud. And I can control the tracks, the volumes up and down. So turn the volume down, pause, that's working, and external socket is still working. I've checked that previously. Switch on the side, back to FM radio.
But it's a lot better than it was.
There you go, and switch back over to Bluetooth. So very pleased with that, very pleased with the functionality, and as I've discovered also, it also depends on what app you're using on your phone. I'm using VLC here, but some apps, I've tried another player app on this, and some of the controls, the Bluetooth controls work and some don't. So it really is down to the compatibility between the Bluetooth commands that's being sent from the little device to the actual player that you've got, and how you've got the player set up. So you know, sometimes it works, sometimes it won't, but I'm quite happy with it playing the way it does. So there we are. Thanks very much for watching. Hope you've enjoyed this little second modification video into modifying. It just goes to show that with a little bit of planning and a little bit of preparation, a lot more than what I've done actually, you can actually add Bluetooth to a non-Bluetooth device, so long as you've got access to the circuit diagram, which thankfully Roberts were very kind to send me the manual for this, and whatever device it is that you've got. If you've just got an ordinary powered speaker, you could even take an old, you know, the old speakers that you used to get you plugged into your computer. You could add Bluetooth to that, and you've got there we are, I've got a Bluetooth stereo system. I've got a system with a nice bass, what do you call it, subwoofer, and that adds quite a really good sound on it, so I might add Bluetooth to that. Who knows, it might be a third video. Anyway, thanks again for watching. Cheerio for now.